Okay, now we're going to talk about geometric sequences, and here's the definition. A geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant. The amount by which we multiply each time is called the common ratio. We call that R of the sequence. All right, that might sound a little more complicated than it really is. So let's take a look at it. Here's an example. And in order to get the next term of the sequence, if I multiply 1 by 3, I get 3. If I multiply 3 by 3, I get 9. If I multiply 3 by 9, I get 27. So it looks like the common ratio, that's what I'm multiplying by, is 3. 3 times 1 is 3. 3 times 3 is 9. 3 times 9 is 27. And 3 times 27 is 81. That's 3, excuse me. So it looks like R would equal 3. So we have a geometric sequence. Each time we're multiplying by 3. That's all. Remember, in an arithmetic sequence we add, we have a common difference. In a geometric sequence we multiply, we have a common ratio. Okay, let's take a look at this example. What do I multiply 256 to get 128? Well, it looks like I multiplied by half. Half of 256 is 128. What's half of 128? 64. What's half of 64? 32. What's half of 32? 16. So it looks like my common ratio there is 1/2. I keep multiplying by 1/2. Okay. Okay, what do I multiply 2 by in order to get -4? Well, I have to multiply it by a negative because it's a positive. So a negative times a positive is a negative, and 2. So it looks like I'm multiplying by -2. Now let's see if that carries out. If I multiply -4 by -2, I get +8. If I multiply +8 by -2, I get -16. If I multiply -16 by -2, I get +32. A negative times a negative is a positive, and 2 times 16 is 32. So it looks like I do have a common ratio. My common ratio is -2. All right. So if we have a common ratio, and you see the pattern for all the elements you can see, then you must assume that it's a geometric sequence. Okay, one more example. I got to make 9 smaller, so I multiply by a fraction, so maybe 1/3 of 9, but it's going to change the sign, so let's say -1/3. Now -1/3 times 9 is a -3. If I multiply -1/3 times -3, and negative times a negative is positive, and 1/3 of 3 is 1, so that's going to work. And then -1/3 times 1 is -1/3, so that's obvious. And a negative times a negative is positive, and then 1/3 times 1/3 is 1/9, so that's going to work. So in this case, our R equals -1/3. So there's 4 real nice examples of geometric sequences. I would just keep multiplying by our common ratio, so if this is my a sub 1, I multiply my a sub 1 by 1 of these to get the second term, or by 2 of these, because 1/3, a negative times a negative is a positive, and 1/3 times 1/3 is 1/9, 1/9 of 9 is 1, so you can see we're multiplying to get the third term by 2 of these, so that's going to lead us to our formula for our nth term. That makes sense. So the nth term of it, or the general term of a geometric sequence with first term a sub 1 and common ratio R is just a sub n equals a sub 1 times R to the n minus 1. So we multiply n minus 1 times to get the nth term. So here's an example. Find the 8th term, a sub 8, of the geometric sequence, -4, 8, -16, 32. So let's take a look at this, and it looks like our a sub 1 would be the first term, which is -4. And what's my common ratio? Well, it looks like I'm multiplying by a -2. Yeah, -2 times 8 is -16. -2 times -16 is positive 32. So my R would be -2. So I just put this in my formula, a sub n, and say we're going to start with the first term, and if we want to get the second term, or whatever term, we just multiply. If we want the second term, we would multiply this by just 1 common ratio. If we want the third term, we multiply by 2 common ratios. So it's just always going to be 1 less than the number of terms. So there's our a sub 1 times r to the n minus 1. In this case, a sub 1 is negative 4. So it's negative 4 times negative 2 to the n minus 1. If we want the eighth term, it's going to be 8 minus 1. Every time you see an n, you put an 8. So let's calculate that out, and we're going to get negative 4 times negative 2, and what's 8 minus 1 is 7. So that's negative 4, and what's negative 2 to the negative 2 to the 7th? Well, since it's odd, a power is going to be odd. If it was even, this would be even. This would be positive. If this is even, this is positive. If this is odd, this is negative. Let's say that. And then 2 to the 7th, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So I have to multiply those out. And negative times negative is a positive. And then 128 times 4, well, 128 and 128 is 256, and 256 and 256 is 512. So that's my eighth term. And that would be too hard to figure out. It's better for larger numbers, but the next term would be negative 64, positive 128, negative 256, and then positive 512. So you could get the eighth term that way also. Okay, so there's a good example of how to find the nth term of a geometric sequence. So I hope you have a good idea of those geometric sequences now.